All right, let's get right into it. Today, we're going to tackle a huge problem in the AI world. You see all these amazing models being built in notebooks and demos, but when they hit the real world, they just, well, break. So we're going to build the bridge that takes an AI model from a data scientist's laptop to a system that actually works in production. And I want to start with a number that's kind of shocking. 87%. That's how many AI projects never actually see the light of day. And the problem usually isn't the model itself. It's that we fail to build a tough, resilient system around the model, a system that can actually handle the messiness of the real world.
And this failure happens in what we call the Great Divide. See, on one side, you've got the data scientist's notebook. Think of it like a perfect, clean laboratory where you can experiment. But on the other side is production. That's a 24/7 factory that has to be secure, reliable, and just always on. So today, we're going to draw the map that gets you across that divide.
Here's how we're going to do it. First, we'll quickly frame the problem. Then, we'll dive into 3 essential blueprints. One for good old predictive machine learning, one for the super popular RAG systems, and a third for the really cutting-edge agentic systems. And we'll wrap it all up with a practical enterprise AI playbook that you can actually use.
Okay, first up, the blueprint for traditional machine learning. The best way to think about these models is as highly specialized calculators. They do one specific job, right? Like predicting which customers might leave or spotting a fraudulent transaction. And the most important thing is that they have to do that job with absolute stability and consistency every single time.
Now, for every single blueprint we cover, we're going to use the same 3-layer pattern. What are the core parts that make it work? How do you keep an eye on it to make sure it's healthy? And of course, how do you lock it down and make it secure? This framework is really the key to thinking about production-ready AI.
So, for our specialized calculator, what are those core components? Well, it all starts with a feature store, which makes sure the data your model sees in the real world looks exactly like the data it trained on. Next, you need a model registry, which is basically version control for your models. Then you've got a high-speed inference engine to get predictions out fast. And finally, you absolutely need a safe deployment strategy, like a canary or shadow deployment, so you can roll out updates without breaking everything.
And that feature store I just mentioned? It's designed to stop this one thing, this silent killer of ML projects, training serving skew. This happens when your model trains on perfect, clean data, but then in production, it gets hit with all this messy real-world data. It's kind of like you studied all month for a history exam, and then the test is on advanced calculus. The model just doesn't know what to do.
Now, once your model is live, you can't just walk away. You have to watch it. That's what observability is all about. You've got to monitor for things like data drift. I mean, is the real world changing faster than your model can keep up? You need data quality gates to stop bad data from ever reaching the model. And you need explainability tools so you can actually ask the model, hey, why did you make that decision?
Okay, this brings us to a huge security rule. This is absolutely non-negotiable. Using a standard Python pickle file to save your model is like taping your house key to the front door. It's a massive security hole that lets an attacker run basically any code they want on your server. You have to use secure formats like ONNX or safe tensors, period.
All right, let's shift gears to our second blueprint, RAG, or Retrieval Augmented Generation. The best analogy here is to think of it as an expert research librarian. You've got this brilliant large language model, but it needs an expert system to go find the exact right information from your company's private documents. So here, the main challenge isn't model stability. It's all about data engineering and getting the facts right.
So how do we build this librarian? First, you need an ingestion pipeline that can pull in and understand all kinds of documents, PDFs, you name it. Then, for retrieval, you want a hybrid approach, combining vector search, which understands meaning, with good old-fashioned keyword search for those exact matches. After you find some potential documents, a re-ranking model sorts them to put the absolute best ones on top. And you have to have an evaluation framework to constantly check if it's all working.
And speaking of evaluation, we measure the success of a RAG system with something called the RAG triad. It basically asks 3 simple questions. 1. Did we find the right information in the first place? 2. Is the final answer actually based on the information we found? This is called groundedness, and it's your #1 weapon against the model making stuff up. And 3. Does the answer actually help the user and answer their original question? You have to nail all 3.
Now, RAG systems have their own special security problems. For example, an attacker could hide a malicious instruction inside a PDF document. Your system ingests it, thinks it's normal text, and feeds it right to the LLM.
That's called an indirect prompt injection. You also have to enforce permissions at the document level, so the AI doesn't show a junior employee a confidential HR file. And of course, you have to automatically find and remove any personally identifiable information.
And that brings us to our third and most advanced blueprint, agentic systems. This is where AI grows hands, you know? It gets the ability to use tools, call APIs, and actually take actions in the real world. We're going to look at the architecture for a single skilled assistant, and then see what happens when you scale that up to a coordinated team of many agents working together.
So, how does one of these agents actually think? Well, it runs on a simple loop. It gets a request from a user, it figures out the user's intent, and it decides if it needs a special tool to get the job done. If it does, it picks the right tool, it runs it, and then it uses the result from that tool to generate its final response to you. That's the basic decision-making cycle right there.
And for an agent to be truly useful, it needs a memory. We're talking two types. Short-term memory is just for tracking the current conversation, like your chat history. But long-term memory is where it stores things like your preferences or key facts from past conversations. That's what gives it a sense of continuity and makes it feel like it actually knows you.
Okay, but the second an AI can take action, security becomes everything. The principle of least privilege is critical. That means its API keys should only grant the absolute minimum power needed to do its job and nothing more. If it can browse the web, you have to protect against attacks like SSRF, and you need really strong guardrails on both its inputs and outputs to stop it from being tricked into doing something dangerous.
But that's just for one agent. What happens when you have a whole team of them? Suddenly, your biggest problem isn't just safety, it's orchestration. How do you manage this whole team of AIs? How do you assign them tasks and get them to work together without tripping over each other? It basically becomes a complex distributed systems problem.
And this leads us to the absolute #1 most important security rule for multi-agent systems: sandboxed execution. Any code an AI writes must be run inside a completely isolated temporary environment, like a Docker container. This stops it from ever being able to mess with your actual production systems. You also need things like agent-to-agent authentication and information barriers, so an agent with access to sensitive data can't just pass it to another agent that, say, posts to social media.
Okay, we have covered a ton of ground here, looking at 3 really different blueprints. So now, let's pull it all together. In this final section, we're going to build a consolidated playbook, a single reference stack that combines all the best tools for building a complete, enterprise-ready AI platform.
And here it is. This is the whole thing in one place. If you're going to screenshot one slide, this is it. Think of it as your cheat sheet for a production AI stack. You can see our recommendations here. For orchestration, something like LangGraph helps manage those complex agent workflows. For observability, tools like Langsmith give you that deep insight. For security, Nemo guardrails give you programmable safety nets. It all runs on a scalable runtime like Kubernetes. Put it all together, and you have a solid foundation for any of the blueprints we talked about today.
So, I want to leave you with one final question to think about. We've just spent all this time architecting the systems to build and control these individual AI agents. But as they start forming their own autonomous teams, the challenge is going to shift from pure engineering to a totally new kind of management. You know, we're building the factory floor today, but tomorrow's job is going to be figuring out how to lead the new digital workforce that's going to operate on it.